All right, let's talk about some more features of trig graphs. We'll start with a review of the sort of correspondence between the graph and the equation, and then we'll talk about other features like maximum, minimum, increasing and decreasing, things like that. So looking at this graph, the first thing I want to do is try to find the equation of the graph. And to do that, I'm going to notice a few things about it. First of all, I see that it's a trig graph, meaning it looks like a wave. It's starting in the middle value and increasing. So that means that it's going to be a sine, and that the number in front is going to have to be a positive number because it's increasing when I'm starting out. That middle number is -2. So that means that that number on the end is -2. I can write plus -2 or just -2. And I also see that the graph goes 3 above that middle value and 3 below that middle value. That means that the amplitude is 3. And then the most annoying thing about this is the period calculation, and that's because it takes a little bit more work. But I'm going to look for one cycle of this graph and try to figure out how wide that cycle is. The way that this is drawn, if I start here at 0, the cycle finishes all the way over here, which I could count ahead and figure out as 16. But if that was off the end of the graph and I couldn't really see it, then another way to recognize one cycle is it's from a minimum to a minimum, or if there was a second maximum, from a maximum to a maximum. So from -4 to 12 is one full cycle, which means that the width of the cycle, which we call the period, is 16. And the formula is that the period should be 2 pi over k. Multiply both sides here by k. I get 16k equals 2 pi. That means that k will have to equal, divide both sides by 16, pi over 8. So pi over 8x goes inside the sign. So the equation of this graph is 3 times the sine of pi over 8x minus 2. You guys probably don't have a graphing calculator at home. You can download the app called Desmos. It's the same as the activities and stuff that we've been doing. They have a graphing calculator app that's pretty good. But you shouldn't need it too much, but I'm going to just check it on here to show you that this should look the same. 3 sine of pi over 8 times x minus 2. I'm going to set my window to be roughly matching this. So from x -4 to 12, y -6 to 2, something like that. What happened here? Oh, I think I see what happened. I messed up the parentheses here, and I need to delete this extra parentheses. All right. That should fix it. There we go. Okay, so this equation does indeed match this graph. By the maximum and minimum values, we can see that it goes up to a value of 1 and down to a value of -5. And then this question, at what x coordinates does the function reach its maximum value? We can see that it reaches its maximum value here at x equals 4. However, even though that's the only one that we see on the graph, that's not actually the only place that this function reaches its maximum value, because we know that it goes in a cycle. So I already figured out the period is 16. It's going to reach that maximum value at 4, and again after 16 units, and again after that after 16 units. So I'm going to write 4 plus 16 n, where n is any integer. So I could choose n equals 0, that would get me x equals 4, that's this maximum. I could choose n equals -1, that would get me an answer of x equals -12, that would be a maximum over here. If you choose n equals 1, that would get you the next maximum, that would be over here. And it's going to continue to reach a maximum every 16 units starting at x equals 4. So we find one that we can see, and then we add the period times n. At what intervals does the function decrease? So we're going to kind of use the same strategy here as we did to answer the maximum value. We can see on this graph that the function is decreasing from x equals, let's see, this should be around parentheses because we're not including the value of 4, but from x equals 4 to 12. This symbol just means that x has to be someplace in this interval. You can read the symbol to say like in, x is in the interval 4 to 12. But this is not the only place where the function is decreasing. If we were to continue this graph, we would see more places where the function is decreasing. So I could also list off the next one is going to be starting from 20, going to 28. The way that I got this number was by taking the 4 and shifting it over by one entire cycle, adding 16. Same for 12 to 28. Add 16 to that number and I get the end point of another decreasing interval. So another way we could write this would be 4 plus 16n to 12 plus 16n, where n is any integer. So any number that you choose for n, you will get an interval where the function is decreasing using this recipe. So we chose one that we could see on the graph, 4 to 12, and then we took those numbers we could see on the graph and just added the period times an integer. Okay. Is this function odd, even, or neither? Let's take a look. So for a function to be even, it would need to be the same if we were to flip it over the y-axis and look at its mirror image. And looking at this, we can see that if we were to flip it around, it would be going the other direction. It would not be even. So it's not even. For odd, we would need to be able to flip it upside down and have it look the same. And we also know that for it to be odd, it always has to pass through the origin. And this is not passing through the origin, so it can't be odd either. It must be neither. But let's also justify this algebraically. If a function is odd, that means that if we take the function and we flip the x value, that's the same as flipping the function value. If a function is even, an algebraic way to describe what that looks like on the graph is that if we flip the x value, it does not change the output of the function. So let's look at this equation. 3 sine pi over 8x minus 2. And let's see what happens if we put in a negative x. This would be 3 sine negative pi over 8x minus 2. Now, it turns out that sine is an odd function. You can see this from the graph of sine that looks like this. If we were to flip this around, it would look the same. That means that sine with a negative sign inside is the same as writing the negative sign outside. So we could simplify this and write negative 3 sine pi over 8x minus 2. So if we compare f of x and f of negative x, this sine part has a negative sign in front. This subtracting 2 has not changed sign. So this changed sign, and this part did not change sign. If everything does not change sign, then it's even. If everything changes sign, then it's odd. And if some do and some don't, then it's neither. So when you plug in negative x, you want to see for each part of the function what happens to the positive or negative sign. Does it change or does it not change? And because we saw part of this changed, part of it did not change, that means that this is neither odd nor even, which you can also see on the graph. If we just had numbers multiplied in front and on the inside here, and we did not have a constant added to the end, this would have turned out to be an odd function. So a sine kx plus c is odd if we don't have a number added to the end. If there was just a number in front and a number inside, we would get an odd result for sine because the function sine itself is odd. If we have a number added to the end, then the whole thing is neither. Okay. Let's see one more example. And on this example, I'm going to give you the equation and not the graph. We'll have to make the graph ourselves. So we have this function, g of x equals negative 2 cosine x over 3 plus 2. So negative cosine means I start at the minimum. This plus 2 is the midline. And this 2 tells me the amplitude. So my midline is at positive 2. And my amplitude tells me that I go up to 2 above that and down to 2 below that. So my equation is going to be someplace in this range. And because it's a negative cosine, that tells me that I'm starting at the minimum. So we've got a pretty good start here. All I need to know is how fat or skinny are these waves? How wide is one cycle? What's the period? To do that, I need to look at the k value. Now, x is being divided by 3, but that's the same as multiplying by 1/3. So k is 1/3. The period is 2 pi over k, which would be 2 pi divided by 1/3, which ends up being the same as multiplying by 3. We get 6 pi. Dividing by 1/3 is the same as multiplying by 3. So our period is 6 pi. This says to include at least 2 cycles. So why don't I make each of these boxes equal to pi. So I can call this 6 pi and this 12 pi. This way I know that I will include at least 2 cycles. And now I'm starting at the minimum. So I'm going to go like this up to here. Halfway through the cycle, I'm at the top. Then I go back to the bottom. That's my first cycle. My second cycle. Here I go up to the top. And then back to the bottom. So here are 2 cycles of this wave, and I'll just draw arrows because we know it does keep going in either direction. Maximum and minimum values. I can see that it goes up to y equals 4 and down to y equals 0. At what x coordinates does the function reach its minimum values? Well, I know that it reaches a minimum value at x equals 0. And then the rule is to take the period and multiply by n, where n is any integer. So, for example, if I chose n equals 1, that would tell me that I have a minimum at 0 plus 6 pi times 1, or 6 pi. If I choose n equals 2, I find this minimum. If I were to choose n equals -1, I would find a minimum over here. And this function is going to have infinitely many places where it reaches that minimum value. Each one of them is going to occur at an x coordinate that is a integer multiple of 6 pi. On what intervals does the function increase? I can see one interval choice would be from 0 to 3 pi. As I move from here to here, my function is increasing. It's not considered increasing at this point or at this point. But then I'm going to do the same thing I did here. 0 plus 6 pi n up to 3 pi plus 6 pi n, where n is any integer. So any value of n that you choose, that's a whole number, positive or negative, will give you an example interval where the function is increasing. So I could even choose a big number like n equals 50. And that would tell me somewhere way over here, off on the right end of the graph, a place where the function is increasing down the line. If you were using this function to predict something in real life that follows a cycle, that would tell you a time at a later date, for example, where you would expect your function to be increasing. is this function odd, even, or neither? Looking at the graph, it does pass through the origin. That doesn't really matter for even functions. It does matter for odd functions. Let's think about if we took this thing and turned it upside down, we can tell that that would not work because right now it's above the x-axis, and if we turned it upside down, it would be below. If we were to take this wave and flip it over the y-axis, we would get, let me label this. We would get the same shape. It would follow the same shape over here and the same shape over here. So this is even, but let's see how that works with our algebraic rules. So if it's even, that means that f of x and f of negative x are the same. If you take x and you replace it with negative x, you get the same answer. And if we take g of x equals negative 2 cosine x over 3 plus 2, g of negative x is negative 2 cosine negative x over 3 plus 2. But cosine itself is even, meaning that cosine of x equals cosine of negative x. So this negative sign inside of a cosine, you basically can just completely ignore. And because these match exactly, our function must be even. The only place where x occurs in our function is inside the cosine. And it turns out that if you take a cosine function and you change the inside, you change the sign of whatever's inside, it does not change the result. A word of caution about odd and even, just to be complete. If you had a number added on the inside of these parentheses, that would throw off your odd and even decisions because it would be introducing a horizontal shift. So if you see a function that has a number added there, it becomes a little more difficult to decide whether the function is odd or even and to find things like the locations of the maximum and minimum values. You won't be expected to do that. You won't be tested on it. But just know that if there is a number there, it throws off the calculations a little bit, and you can't use necessarily the same simple rules that we've been going over. We can see here that when you add something to cosine, it does not throw off the fact that the cosine is even. So f of x equals some number cosine kx plus c is always even. Any of these numbers can be anything. They can be there, they can not be there, they can be positive or negative. The result will be even. All right, hope this was helpful. Reach out to me if you have any questions. There's going to be an assignment that's similar questions to this. If you need help with that, feel free to ask. And also, after you submit, I'll give you feedback, and if you want, you can correct your answers. Hope everybody is having a great week. I'll talk to you again soon.